going to be visiting section 2 again. And if you remember, on Tuesday, I taught you how to graph quadratic equations when they were in the form y equals ax squared plus bx plus c. I'm not sure why I'm seeing pull-on faces.
That's not good. I am drinking, so don't look at me.
All right, but just in case you weren't paying attention or you don't remember, we're going to go ahead and review this. When it's in the form y equals ax squared plus bx plus c, we have an a, which is the coefficient of the x squared. We have b, which is the coefficient of the x, and we have the c, which is the constant. Okay, Josh, you can't be drinking the whole time so that you don't ever have to wear your mask.
Well, I was gonna drink and then he was trying to like do something. I will distract
All right, now each of those ABCs have different roles to play in the graph of that quadratic function. So let's remind ourselves of what happens. We first of all have to identify the ABCs. So what's my A from the problem, Hunter? Right here.
2.
All right, Sean, what's B? 4. And what is C, Lauren? -3. Now that we have that, we start with step 1. Step 1 says I take NUV x equals -b over 2a. By the way, this formula is going to come in super handy today. We're going to use it a lot. Because it's not only the axis of symmetry, it also provides us with huge amounts of information when we're dealing with word problems. Put your mask up. Don't care.
I'm double maxed up.
All right, so you guys, we're going to plug in our b. So that would be -4 over 2 times a, which is 2. We have -4 over 4, which is -1. Now that is my axis of symmetry, -1 right here. It is also the x of my vertex, so then I'm going to plug it in. This is step 2. I plug it in to solve for y. So -1 just plug in here. I want to say this is the same one we did the other day. -1 squared is 1. 1 times 2 is 2. 4 times negative, maybe we didn't. And I want to say we get -5, right? So x equals -1, y equals -5. So -1, -5 is my vertex. And then the last thing is that I haven't used yet, the c. C is my y-intercept. That's step 3. Okay, so on the y-axis I put -3. I connect from, it has to be in this order. Go vertex to y-intercept. And once I have that side, I can mirror image it over on the other side. Okay, so that is what we did on Tuesday. But now, we get more problems. We touched on this briefly, but when we have y equals ax squared plus bx plus c, and we're talking about how this affects, like in real world, the springboard, the diver, the whole thing, that this is the height off the ground. So that's the constant. The constant stands for the height off the ground. The A is the gravitational force really need to pull that up. If I was playing baseball and I hit the ball, Josh, I need you, guys, I need you to be quiet, okay? Notice that there are several individuals in this building that are double vaccinated are still wearing their masks, okay? Because it is still a mandate from the governor. Hey, stop. Yes, and I'm not asking for your opinion right now.
Ooh.
All right, so you guys, when we have an athlete that dives from a 3-meter springboard, for altitude y at horizontal distance x can be approximated by the function y equals negative 2.2x squared plus 5.3x plus 4. Both the altitude and the distance are in meters. Question is, how far has she traveled horizontally when she reaches her maximum altitude? Round to the nearest 10th meter. And then question B says, what is her maximum altitude? Let's draw a picture of this. All right, so here is her springboard, right? The path that this diver is going to take is probably going to look something like this. Correct? Which is a partial parabola. Notice? We're looking for her maximum altitude. Where's the maximum altitude? On the at the top. Do you know another name for that?
The vertex.
The vertex. If I can find the x and y of the vertex, I'm going to find out how high she went and how far over she was, her horizontal distance was. So I'm looking for the x and y of the vertex. So here I want the x of the vertex, and here I want the y of the vertex. Well, how do I find the vertex of a problem? Maddie? Yeah, you know the formula I said was super important, so we're gonna use it today? Yeah, that's it. X equals negative b over 2a. That's gonna give us the x of the vertex. And then how would I find the y of the vertex? By plugging that into the equation, just like we did yesterday to find the vertex of the equation so that we could graph it. So let's identify our ABCs first. We have A is, here's our equation. What's our A? Negative 2.2. What's our B? And what's our C? Yeah, that's irrelevant. We don't need C today. Okay, so let's plug that in. Negative B, so that would be negative 5.3 divided by 2 times negative 2.2. Well, 2 times negative 2.2 is, I believe, negative 4.4. So this is negative 5.3 divided by negative 4.4. We're supposed to round to the nearest 10. 1.2? So that means is 1.2. What does the x stand for? No, in this case, it stands for the horizontal distance, and everything is in meters. So 1.2 meters horizontally from the diving board, where she dove from, is going to be our x value, right? Okay, so now let's plug that in to solve for our maximum altitude, which is going to be y equals negative 2.2 times 1.2 squared plus 5.3 times 1.2 plus high she got? 7.2? 1?
7.192.
Okay, so then run it to the nearest term for 7.2. So she is going to get to a full altitude of 7.2 meters, which wasn't bad. She was on a 3-meter springboard, so that's pretty good height there. I guess you get a little spring from the board, all right? Okay, does that make sense? Is it anything different than what we did on Tuesday? We're doing the same steps. It's just applying it to a word problem instead. Jacob? Okay. All right. So let's try another one. This one's kind of cool, especially as Blooming Prairie is known for their fireworks displays. In professional fireworks displays, aerial fireworks carry stars upwards, ignite them, and project them into the air. Suppose a particular star is projected from an aerial firework at a starting height. I'm not sure why there needed to be talking involved. Okay, so a particular star is projected from an aerial firework at a starting height of 520 feet. So here's the deal. You know how the canisters, they're shot up into the air and they get to a certain height, and then that's when they separate, it explodes, and they separate into all of these. Well, we're saying that this is 520 feet in the air when that explosion takes place. Now what happens is we're going to follow one of these guys in its path as it falls to the ground. The initial velocity is 72 feet per second. Now it says, how long will it take for the star to reach its maximum height? How far above the ground will it be? Guess what we're looking for? The vertex. So whenever it says maximum, we're looking for the maximum, or if we're looking for a minimum. So you guys, anytime you hear that, and that's part of the directions, your mind should automatically go to this formula, because that is what they're looking for, is that vertex formula, okay? So since this is a maximum, we're looking for the maximum. My equation is this. It says h equals -16 t squared plus 72t plus 520. You see where all those numbers came from? Where did the -16 come from? We've talked about this before. What is the negative? Where did they get the -16? Did they just from the thing all the way to the top? This is a number that we've had before in our problems. Brady? It's a gravitational force. So -16 feet per second squared is the gravitational force. If it's in feet, if it's in meters, we have -4.9. Okay, but since it's in feet, we have -16. So this front number, when we're dealing with height and time, will always be that -16. Where did the 72 come from? The velocity. Where did the 520 come from? That's how high it was when all of a sudden it had this burst of energy with the 72 feet per second. Okay, so I've got a big mess here, so I'm going to clean some stuff up so we have some space to work with. All right, so what is our A? What's our B? Do I need the C? No, so not right now. My first step then is to plug it where, Grady? Where am I going to put my numbers? What am I looking for? No, just both of them. We're gonna put both of them. Sophia? Because you're using this formula right here. So we have negative 72, because that's the B, over 2 times the A, which is negative 16. So we have negative 72 divided by negative 32. And negative 72 divided by negative 32. Anybody? .25. So it's going to take 2.25 seconds because that's what our x is, right? Time. It takes 2.25 seconds to reach its maximum height. But the real question is, how high does it get? What is this point right here? How high is that? What do I do, Maddie?
I believe gets you up to 600 one.
Yeah, I'll double check here. 5 squared times negative 16 is negative 81. And then 72 times 2.25 is 162. And then we do the math and we get, I got 601. 601. 601 feet is how high that one part of the fireworks display is going to get. All right. Guys, this assignment is due tomorrow. I have it on paper, but I also have it online.